Good afternoon, everyone. I am Pritam Mishra, Assistant Professor of G.I.T. Ghangapatna, Bhubaneswar. Today, my topic is moving iron MI instrument. What is moving iron MI instrument? The instrument in which the moving iron is used to measuring the flow of the current or voltage is known as moving iron instrument. It works on the principle that the iron placed near the magnet and attract towards it. The force of attraction depends on the strength of the magnetic field. The magnetic field included by the electromagnetic whose strength depends on the magnitude of the current passed through it. Let's discuss about construction of moving iron instrument. Instrument consists of stationary coil in which the current to be measured is passed. A piece of unmagnetized soft iron which is of oval shape is mounted readily on the spindle. The soft iron pieces is freely to move about the spindle and along with the spindle. Let's talk about working of moving iron instrument. The current to be measured is flowing in the coil, produce a magnetic field. Iron pieces get attracted towards center of the magnetic field and pointer reflected on the scale. Controlling torque is provided either by controlling spring or by gravity control method. Damping is provided by air friction damping. The scale is nonlinear. Mirror is provided to avoid parallax error. Moving iron instruments are two types: attraction type MI instrument and repulsion type moving instrument. Let's discuss about attraction type moving instrument. Construction of attraction type moving instrument. The instrument consists of stationary coil in which current that is to be measured is passed. A piece of unmagnetized soft iron which is oval shape is mounted readily on the spindle. The soft iron pieces is free to move above the spindle or along with the spindle. It is placed closer to the stationary coil shown in the figure. A pointer is fixed on the spindle. Let's discuss about repulsion type MI instrument. Construction of repulsion type MI instrument. The instrument consists of two iron, where one is attached to the stationary coil and other is attached to the movable spindle. Both are surrounded by the stationary coil. Current to be measured is passing through the coil. Let's discuss about repulsion type MI instrument. Construction of repulsion type MI instrument. The instrument consists of two iron bands. One is attached to the stationary coil and other one is attached to the movable spindle. Both bands are surrounded by the stationary coil. Current to be measured is passed through this coil. Working of repulsion type MI instrument. Current to be measured is passed through stationary coil, produce magnetic field. Both the bands magnetized with similar polarities. As a result, force of repulsion is set between two bands. This force produces a deflecting torque on the movable bands, gives deflection on the scale. Generally, torque equation of MI instrument TD equal to 1 by I square dl by dt. Let's talk about permanent magnet moving coil instrument. Construction of permanent magnet moving coil instrument. The consists of permanent magnet which is stationary moving system consists of a spindle attached to the rectangle aluminum frame. A coil made of thin copper wire is wound over the frame. The current to be measured is passed through this coil. A soft iron core is placed in the space of within the aluminum frame. Two spiral springs are mounted on the spindle to produce controlling torque. Controlling spindle also serves an additional purpose and act as a controlling lead. Pointer is mounted on the spindle. Mirror is provided below the scale to avoid parallax error. The spindle is supported by the bearing. Working of permanent magnet moving coil instrument. The current to be measured is passed through the moving coil by controlling springs. A current carrying moving coil is now its magnetic field. According to the Fleming left-hand rule, torque is produced on the coil and coil moves, pointer deflects. Dumping torque is provided by eddy current dumping method. Torque equation deflection is proportional to the current. Error in PMMC instrument. Weakening of permanent magnet due to the aging and temperature effect. Weakening of spring due to the aging and temperature effect. Changing of resistance of moving coil with the temperature. Merits. Uniform scale is for the instrument. Power consumption is very low. A single instrument can be used for different current and voltage range. The torque weight ratio is high, gives higher accuracy. Demerits. The instrument can be used only DC supply. The cost of the instrument is more than MI instrument. Let's discuss about electrodynamic instrument. What is electrodynamic instrument? An electrodynamic instrument is a moving coil instrument in which the operation field is produced not by a permanent magnet but by another fixed coil. This instrument can be used either an ammeter or voltmeter, but it is generally used in wattmeter. Then discuss about construction of electrodynamic instrument. A secondary part consists of two fixed coils connected in series as shown in the figure. This is the L1 part, this was the L2 part, so that they carry same current. The moving system consists of coil mounted on the spindle which is freely to rotate in the space between the two fixed coils. This is the movable part of the spindle rotating towards the moving coil. The coil is made of thin copper wire and air core above the hysteresis. Controlling torque provided by the two spiral springs. They also act as connecting lead of the moving coil. Pointer is mounted on the spindle. Mirror is provided to avoid the parallax error. Damping torque is provided by the air friction damping. Let's discuss working of electrodynamic instrument. Current to be measured is passed through the two centenary coils which are connected in series form in the magnetic field. Current to be measured also pass through the moving coil via controlling spring. Now current carrying moving coil is placed in magnetic field. According to plain left-hand rules, force is experienced on the moving coil gives deflection on the pointer. Torque Td is directly proportional to the I1 into I2. I1 is current flowing through the fixed coil and I2 is current flowing through the moving coil. Merits of electrodynamic instrument. It can be used an AC as well as DC. It can be used a ammeter, voltmeter and wattmeter. It is also a dynamometer instrument. Demerits of electrodynamic instrument: low torque to weight ratio, more expensive, weak magnetic field, scale is not uniform. Let's talk about electrodynamic instrument as voltmeter, ammeter and wattmeter. When used as ammeter, the fixed coils are made of thick conductor to carry load current, but since it is not possible when moving coil, it is shunt connected in parallelly, which is suitable resistor. When used as a voltmeter, a coil are made from less cross-section conductor to increase instrument impedance. To increase the instrument impedance, a heavy resistor is connected in the series with them. When using a wattmeter, fixed coils are used as a current coil and the moving coil as a pressure coil. Constructionally, fixed coils are made of thick copper wire and moving coil with the conductors. Thank you.